Previously, we have been looking at the monochromatic wave, but right now we want to try to understand what a wave group or wave packet means. Now, when a wave is generated in the offshore region, as we mentioned, it may happens because of a storm or basically due to wind shear effect on the surface of the water. But we can also easily generate a series of wave or a train of wave simply by disturbing the surface of water using our finger. Now when the disturbance happens, the first wave is generated, and subsequently from the same point it will continue to um, emanate or send out wave in all direction. How exactly does this happen? Now when the first wave is generated, the wave moves forward, and when it moves forward, the wave lost a little of the energy that it has, or basically it leaves behind a little of its energy as it propagates. So the energy that the first wave leaves behind actually forms the second wave, which is why uh, when we disturb the surface of the water, we don't get just one wave, but we will get a series of wave, a train of wave. Okay, so the wave energy that is left behind form the second wave, and so on. And of course, um, the energy that is left behind is limited, so eventually the wave that is produced will cease or will stop. So we have what we say a wave packet, whereby a wave packet is made up of a number of waves, whereby the first wave at the front is the smallest because the one at the front has already lost most of its energy. Okay, and also the wave at the back is also the smallest because of the limited residual energy left. Basically, the last wave is not able to leave behind any more energy to create the next wave. But whereas in between the first and the last wave, we are going to see a wave train whereby the amplitude may changes from the beginning until the end, but the wave period will be the same from one wave to another wave. Now, this phenomena actually causes the entire group of the wave to move forward at a different speed from the speed that the individual wave is moving. Okay. Now, because of the phenomena of the energy loss from the wave at the front to the wave at the back, so generally when the wave group is being created, um, as the number of waves increases, then the overall amplitude of the entire group will decrease. You can think of it this way: if you are able to disturb the surface of the water and generate only one wave, then the amplitude of that wave will remain because it doesn't create any other wave. But if you only disturb once and the one wave break down to 2 to 3 to 4 to more and more wave, then the overall energy is being distributed out so that the amplitude of all the wave becomes smaller and smaller. Now because the wave group and the individual wave move at a different speed, so usually in analysis of wave arrival time is based on the group velocity. This illustration shows us how the wave group is moving. We can see this is one group of wave whereby we have smaller wave amplitude at the front and then it grows to a larger amplitude, and we have smaller amplitude at the back. You can see how this group is moving, which is quite slow if we compare to the two dots, which represent how fast the individual waves are moving. So clearly the wave group is moving at a smaller velocity than the individual wave. This figure illustrates the envelope of the wave group compared to the individual wave that is nested inside it. As we mentioned, the group velocity is different and is usually smaller or slower than the individual wave celerity. So if we write the ratio of the group celerity over the individual wave celerity, then this value or this ratio n is always less than or equals to 1. Now this animation here shows how the wave group evolves over time. Imagine if this is a still water surface at the beginning, and let's say a storm occurs and disturbs the water surface here, then a series of waves is created. You notice that when the wave is first created, there are only a few wave height. Actually, of course, it started with only one. But as the whole group of the wave propagates away from its source, you notice that the number of waves becomes more and more, because every time it moves forward, a new wave is created behind. When the number of waves becomes more and more, you also notice that the wave height of the entire group generally becomes less and less. This is the phenomena of the wave group propagation. One group, very high, spread out more and more, and becomes lower and lower with more individual waves. So the ratio n is found to be given by this expression. It depends on the term kd. As usual, k is 2 pi OL, the wave number, d is the water depth. In general, n will be equals to 0.5 in deep water, whereby the term inside this bracket equals to 1, so we are only left with 1 over 2. And in shallow water, n equals to 1. What does that mean? It means that in deep water, the wave group celerity is only half of the individual wave celerity. But when it comes to the shallow water, then both the individual wave and the wave group will be moving at the same speed. So n basically increases from 0.5 to 1 in the shoreward direction. Except in shallow region, wave celerity always exceeds wave velocity, and so we say that the waves are dispersive.